continuous at x equals c. Let me say this in specific example for this problem now. The specific example for this problem is the limit as x goes to 6 of f of x was equal to 1. We did that on problem 3. F of 6 was undefined. 1 does not equal undefined. Therefore, that's the math symbol for therefore, the 3 dots. Therefore, f of x is not continuous at x equals 6. And everybody in this room, if I had asked them before, if I had said, is the function continuous at x equals 6, everybody would have said no, because you have to lift your pencil. This is a little bit more mathematical way than just saying I have to lift my pencil. Questions so far?
Well, then for F, it's undefined because it actually touches wood.
Because open circle?
Yeah.
Okay, let's keep going. So number 5. Sorry, skip 5 temporarily. Skip 5 just temporarily. We'll come back to it. Just temporarily, please. Alright, so number 6. We want the limit as x goes to 2 from the left. That's what we want. The limit as x goes to 2 from the left. So here's 2. Draw the wall. And you want to approach this orange line from the left. It says approach from the left. So just don't even care about the right side. So as the graph gets closer from the left, I'm getting closer, I'm getting closer, I'm getting closer. The y value is getting closer to 5. We do not care what happens on the right. We do not care what happens at the wall. We just care about what happens on the left as we approach the wall. Questions? Okay, those who are good with that can push forward to 7, 8, 9. Are there questions on 6? If not, I will do 7, 8, 9 silently up here. You can verify your answers by looking up here. And of course, don't hesitate to stop me with questions. And you may have a little trouble on 8 because we haven't really discussed it, but attempt it if you can, and then you'll see. But 7, we should be good. Let me stop and see if there are questions on 7. If you've already done 7, my answer's up here for 7. Okay. So we're looking here. Here's our wall. And we want to know what happens as we approach the wall from the right. So do not care about the left side. So as I'm approaching this wall from the right side, the y values are going down, 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 and the y values excuse me, are getting closer and closer to 1. Now on number 9, we can introduce a new rule. The rule on number 9 is number 8, sorry. If the limit as x goes to c from the left does not equal the limit as x goes to c from the right, then the double-sided limit is does not exist. Oh yeah. Oh, that's right. Good, that's right. I wonder if that could be. Yeah. You should do that. So basically what we're saying here is if the limit from the left, in this case was 5, the limit from the right, in this case was 1, certainly 5 does not equal 1, therefore the double-sided limit does not exist. Questions? Number 9, any questions on that? Okay. Let's go to number 10 and 11, which are back on page 6. Again, my apologies on the numbering snafus. So number 10 is just f of 5. Again, many of you all can do that on your own. Verify with me once you have attempted it. Just verifying with me, please, that you guys are getting this. You can skip number 12, like, you can just scratch it out. If there are no questions, if you don't have any questions on 10 or 11, go to 13. Attempt it on your own, just try it. Try 14. Before I go on, I want to see if there are any questions on either 10 or 11. No questions on 10 or 11. Remember, we're going to skip 12. Go ahead and scratch it out. Again, try 13 and 14. Once you've made a guess, you can look on mine. Okay. 15. So are there any questions on either 13 or 14? Please let me know. Edgar, go ahead, please.
Did you get the 13?
Okay. So I'm looking at the graph. They're asking what happens when I go to infinity. So infinity is like way over here. Excuse me. This graph is going down and it's approaching 0. It's approaching this y equals 0 right here. Does that work?
But you know, positive, so where is it close to that?
No, but it's approaching infinity, right? So I'm going this way. Here's infinity is going this side. Yesenia, your question? Same one? Okay. 15, if you're already there, great. 16, can verify those two. And then we'll do 17 and 5 together. So remember, we had skipped 5 temporarily. But first I want to make sure that we're all good up to 16. If you're good up to 16, just try 17 and 5 on your own. You might be able to, you know, learn something, make some headway. No problem there. Eddie, go ahead, please. Okay, yeah, sure. Number 10 right here.
Yeah.
So that's saying f of 5. So that means when I plug in 5, what do I get on the graph? So here's 5, so I get negative 3.
Why is it negative 5? Why is it
Huh?
Why is it negative 5?
I'm not, this is positive 5 for x.
Oh, okay.
Alright. So 15, 16. Let's move to 17. Folks. 17, please. 17 says identify the values of c where the limit, specifically the double-sided limit, does not equal the value of the function. So where does the double-sided limit not equal the value of the function? This is another way of saying, where is the function discontinuous? Anytime the limit does not equal the value of the function, that's like saying discontinuous. The values are, of course, 2 and 6. Because at 2, this function is equal to 1, and the limit does not exist. At 6, the function does not exist, and the limit equals 1. And finally, number 5. On number 5, they're asking me the values where the limit as x approaches c from the left equals 1. And here are the values I'm getting. Verify you see why. Questions on number 5?
Number 5, how did you
Guys, too much noise here. Edgar, go ahead, please. Because, so here's 6, this brown line. The limit as I approach from the left, so I only care about the left side right here. As I'm getting closer and closer from the left, what is y doing? Y is getting closer to 1. This way, please. Why not 2? Okay, so here's 2. So there's the wall. I want to approach from the left. When I approach the wall from the left, though, I'm going up to 5. Do you agree, Josue? All right, let's take a 1-minute break, and we'll come back together. Okay, so I want to pick up, guys, with doing something slightly different. I want to talk now a little bit about how to find limits with the calculator. So we talked just now about finding limits graphically, but now I want to talk about finding the limits with the calculator. So I'm on page 5, bottom of the page. Please scratch out problem 2. And on problem 1, I forgot to actually write the questions there, so the questions are as follows. Guys, there should not be any discussion. Folks, shouldn't have any discussion right now. Here's what we need to find for problem 1. And again, I just forgot to type this. On all the other problems, they're typed correctly. It just got left off here. So we need to find